To finish up, we are going to do section 6.6, which is the trigonometric form of a complex number. The part of the section that we are doing can be found on pages 445 through 447 in your textbook. So let's begin by looking at what is the trig form of a complex number. Last section we reviewed what is known as the standard form of a complex number, which is the a plus bi, here we go, which is the a plus bi form. This section we're going to look at the trig form, which can be seen here, which is r times cosine theta plus I sine theta. Notice if I were to distribute that r, you are still going to have a real part, which is going to be r cosine theta, which takes the place of a, and you are still going to have an imaginary part, which would be r sine theta, which takes the place of b. Using these conversion equations here that are bulleted, we are going to do a few examples that convert back and forth between the standard form of a complex number and the trig form of the complex number. So, for example, in order to find r, we are going to take the square root of a squared plus b squared if we are trying to convert to the trig form. This is also known as the modulus, which we discussed in section 6.5, the modulus of z, or the absolute value, we called it at that point too. And then in order to find theta, or the argument of z, theta is found by taking b divided by a, and then evaluating at what angle does tangent equal this b divided by a ratio. So let's do a few examples. So the first one here, we're going to convert this complex number -2 minus 2 square root of 3i to trig form of a complex number. In order to do this conversion, it's very important to first visualize where this complex number is in the complex plane, like we did in last section. So if I think about this complex number, it would be the same as -2 square root of 3. If I were to graph that, I'm going to make a quick sketch. So this is the real axis, this is my imaginary axis. I would go backwards -2 and then down this -2 square root of 3, and I'm just going to estimate where that is. We don't need an exact point. So it would be somewhere in here, and this is just telling me that I know this point is going to be in quadrant 3, which is going to be important when we start calculating theta or the angle later. So now if I want to change this to trig form, so trig form is r times cosine theta plus I sine theta. We are going to need to find r, and we're going to need to find this theta value. So let's find r first. So r is the square root of a squared plus b squared. So the square root of -2 squared plus -2 square root of 3 squared. So that's going to give me the square root of 4 plus 12. 2 square root of 3 squared is 12, which gives me the square root of 16. And so r is 4, or the modulus is 4. Next, let's find theta. So tangent theta is equal to b over a. So -2 square root of 3 over -2. The -2's are going to simplify, and we're looking at tangent of theta equaling the square root of 3. When we think about our unit circle, the first place that tangent is equal to the square root of 3 is when theta is equal to pi over 3. But we already know that our point, this -2 square root of 3, that's in quadrant 3, whereas this pi over 3, that's in quadrant 1. So I need to change this theta so that it's in quadrant 3. In order to do that, I'm just going to add pi to it. So when I add pi to it, I get 4 pi over 3, which is another angle at which tangent is equal to square root of 3. And this is the angle that we're looking for, considering I want my point to be in quadrant 3. Okay, so now let's just finish by actually writing our number in trig form. So z equals r is 4 times cosine theta we found is 4 pi over 3 plus I sine 4 pi over 3. And that is the same complex number in trig form. Okay, let's keep going. Let's do another one. So let's first visualize where this complex number would be. So this complex number is the same as 10 plus 0i. So if I were to plot that, that would be 10, 0. Let me do a quick sketch. So this is the real axis, this is the imaginary. So it would be 10 over on the real axis, so that's where that point would be. Okay, let's go ahead and find r and theta. So r is the square root of a squared, so 10 squared, plus b squared, which is 0 squared. So that's the square root of 100, which is just 10. So r, or the modulus, is 10. Now let's find theta. Tangent theta is b over a, so that's going to be 0 over 10. So tangent theta equals 0, and two places at which tangents equal to 0 is when theta equals 0 or pi. If I look at my graph, we know that we want the angle 0 and not the angle pi because of where it's plotted. So now we will write it in our trig form. So z equals 10 cosine 0 plus I sine 0. Okay, and now let's go backwards. So now they're giving us the complex number in trig form, and we are going to convert this back to standard form. This is actually pretty easy. Basically what we're going to do is evaluate each of these values and then just distribute our r value of square root of 5. So we have square root of 5. Cosine of negative pi over 3 is 1/2 plus I sine of negative pi over 3 is negative square root of 3 over 2. And now we're just going to go ahead and distribute our square root of 5. So if I make that square root of 5 over 1, I get z equals square root of 5 over 2. And then I'm going to do minus because of this negative. And square root of 5 times square root of 3 gives me square root of 15 over 2i. And so that is going from the trig form to the standard form. Okay? To finish up this lesson, we are going to look at a few operations with these complex numbers in trig form. So last section we looked at adding and subtracting the complex numbers. This section we're going to look at multiplying and dividing them when they are in trig form. In order to multiply, to calculate the product, we are going to take, so you'll have two different complex numbers in trig form. You're going to multiply their r values, and then you're going to add their theta values, okay? In order to find the quotient, or when you're dividing, we are going to divide their r values, first divided by the second, and then we are going to subtract their theta values. Okay, so let's do a couple examples with that. So we are going to find the product. We are going to multiply these two complex numbers in trig form, and we are going to leave our answer in trig form. So really important that you look at the directions for how they want you to express your answer. Okay, I'm going to go through all the steps. So we're going to start with multiplying our r values. So 3/4 times 4. And then we are going to add our theta values. So pi over 3 plus 3 pi over 4 plus I sine pi over 3 plus 3 pi over 4. Okay, and so if I take now 3 over 4 times 4 over 1, the 4's will cancel, leaving me with an r value of 3, and then cosine pi over 3 plus 3 pi over 4. If you get a common denominator, add those together, you will get 13 pi over 12 plus I sine 13 pi over 12. And they want us to leave our answer in trig form, and so that is our final answer. Okay, let's do a division. So we are going to find the quotient, and again, we are going to leave our answer in trig form. So here, this r value is assumed to be a 1. So if we divide the r values, we get 1/2, 1 divided by 2. And then cosine, we are going to subtract the theta value, so 120 minus 40 degrees, plus I sine 120 minus 40 degrees. Okay, now we're going to simplify everything. 1/2 will just stay 1/2. And cosine of 80 degrees plus I sine of 80 degrees. And again, we're leaving our answer in trig form. Okay, moving on. So we're going to find the product again. And this time it says in the complex plane. So these directions are a little different. This is telling me then that I want my answer to be expressed in standard form. So we're going to express our answer in the form a plus bi after we multiply this together. Okay, so I'm going to skip a couple steps with this one. I'll talk through it. So the first thing that I'm going to do is multiply my r value. So 2 times 3, that gets me 6. And then I'm going to add my theta values as I go. So cosine pi over 4 plus pi over 4 is going to give me pi over 2. And then plus I sine pi over 4 plus pi over 4 pi over 2. Okay, so there's my answer in trig form. I want to change this to standard form. So just like we did before, keeping the 6 out in front for now, cosine of pi over 2 is 0, plus I sine of pi over 2 is positive 1. And now I'm just going to distribute my 6. So 6 times 0 is 0, plus 6i, which is just 6i. So notice my answer in standard form, 6i. And let's finish up with a quotient then, also expressing it in the complex plane, meaning expressing it in standard form as opposed to trig form. And I'll skip a couple steps here as we go again. So 24 divided by 8, that's going to give me an r value of 3. And then if I subtract 300 minus 75, I get 225 degrees plus I sine 225 degrees. So there's my answer in trig form. Let's convert that to standard form. So 3 cosine of 225 degrees is negative square root of 2 over 2 plus I sine of 225 degrees is also negative square root of 2 over 2. So now if I distribute that 3 over 1, I get a final answer of negative 3 square root of 2 over 2 minus 3 square root of 2 over 2i. And that is all for complex numbers.